Welcome back, Algebrists. Today, we are reviewing all of factoring. Now, I do want you guys to know, check it out, GCF. We'll do a problem with GCF for sure. Number two, what do we check for? So, I like where your head's at. You skipped one little part, but kind of. It's a binomial. And then for this, I'm just going to write difference, diff, and I'm just going to draw a square. Difference of squares. Cool. If it was, awesome. If it wasn't, awesome. What's step 3? We check to see if it's not a binomial, but a trinomial. Okay. For trinomials, this order is not really super important, but there's 3 things that I check for right off the bat. The first is if it's a perfect square trinomial. We'll look. I mean, you can talk now, but we will look at one. I'm sorry, I didn't mean to shut you down. Okay. If it's a perfect square trinomial and you want to use the shortcut for perfect square trinomials, awesome. We'll see what that looks like here in just a second. I will probably never write this again. Shorthand, anybody recall? How would I shorthand a perfect square trinomial? So more specifically, like this is my shorthand for greatest common factor. PST. Good. Okay. If it's not, or you don't like perfect square trinomials, that's fine. I'm going to write this down. I'm going to say leading coefficient, which we normally just write LC, but I'm cool with that. The leading coefficient, LC, and I'll even pause on that. What do we hope it is, that leading coefficient? We hope it's a 1. Now, on your test, if you look closely in the directions, it says if this is the shorthand you're using, or the shortcut, you can just use LC1. Now, you can call it LC1, you can call it shortcut. I don't really care what you call it, as long as I know what you're talking about. I'm good with it. If it's not a leading coefficient of 1, so this one I am going to shorthand. If the leading coefficient is not 1, what do we use? We use grouping. Okay. Now, this whole, it's what I call the roadmap. I know it doesn't really look like a map. But all of this right here is simply the way to do what to an expression. This is how we factor it. Now, on the test, there is something fundamentally different about just regular factoring questions, or the quiz rather, about just regular old factoring questions and what I was asking you to do. I didn't ask you just to factor. What did I ask you to do with each of the following? Or like, if you look at it, what were you actually being asked to do? You had to factor. Annotate it. So I was looking for all this stuff. That's 1. So if you got the right answer, but you still had -1, it's just because I didn't get that from you. But the big part of this, and I'm going to make this comment, we use factoring to solve equations. Now, every single time, we use factoring to solve equations, and then I'm going to add one more little tidbit here. Using what we shorthanded as, and before you write it, I want to make sure that we know what this is. ZPP. Now, talking about stuff is all fine and dandy, but if you don't know what ZPP is, then there's no value in writing it down. They give you the option again still? No. Good. Don't do anything else if you're in there. You're good. We all have the same screen, it looks like. I don't know why there's 2, because I deleted every other possible option. We'll come back to that. Work on your other stuff for now. Okay. Thank you guys for checking. If you've already closed it, it's too late. If you haven't closed it, just minimize it. I'm going to post something here in a little while, and I want to see if it shows up and where it shows up. Okay. So check it out. What's ZPP? The 0, it's not point. Product property. Okay. Now, every single equation we will solve with factoring, but then we're going to finish it, like we factor it, and then we use the 0 product property, which if you're okay with that language, awesome, but we need to make sure we all can see not only how to phrase it, right, ZPP, but what it actually means and what it entails. So, I can work these exact questions, and I think that we probably would benefit from it, with the understanding that some of you got some of them right, and they might be a little redundant. but it will never hurt you to do practice problems. Okay, so let's dive right in. And it's straight up like we'll take a brain break at some point, and you guys will just tell me when you want the brain break, because I could start now and just keep going and going and going. Sweet. So on a sheet of paper on the back of your test, wherever it is, we are going to solve each of the following. Does everybody have this first? This. All right, cool. So here we go. We're just going to work through the whole quiz, and then we'll start adding more problems. Okay, so on number 1, we have the following equation. It is 2x squared minus 72 is equal to 0. Yep, we're going to do every single one of these, and then we'll do a bunch more that weren't these, because I hope that it's not the exact same one that we're going to work, but it could be. Like, I'm not intentionally, but it could happen. Okay, so here we are. We're trying to solve this. Now, we have to factor, or if you want a little bit positive spin, we get to factor. Difference in language feels different. All right, what do we always check for first, every single time? Is there anything that goes into both of these? 2. Everybody agree with that? Okay, if you need a calculator, you can grab one. But if we factor a 2 out, or if we divide it by 2, what's left behind here? X squared minus 36. Now, it's still equal to what? Now, notice, I'm not going to deal with this on this side right now, but we don't want to leave it behind. Okay, for this, what type of factoring did we just use? So here it is. Here's my annotation. We just did the GCF. That's it. Okay, if you're wondering why you missed a half a point on number 1 or number 3 or 4, anybody who's over there, you're about to find out. Cool. All right. Now, on our next line, we have to keep going, and we're not going to leave stuff behind. This is a factor right now. So it comes along for the ride, but I want to focus on this part. Now we're just going to restart. And we're just going to go through the list at each individual little piece. Is there a greatest common factor between x squared and 36? No. Is it a binomial? Do you know the square root of this? You know the square root of this? Yeah. Is it a difference? Yes. So is this a difference of 2 squares? Okay. We did not write the formula on the cheat sheet just now. We will. We'll generalize this. Does anybody remember, and we'll just do that right now so that we can automatically apply it. Anybody recall how this works? And we're going to put an example here. And we can even put that example. The one that I had before was a squared minus b squared. That's the one that I'd used before. This is 2 things that are both squares, and it's a difference. Does anybody recall how these factor? A minus b and a plus b. This is the rule for the difference of 2 squares. Now, I would add that to your roadmap, your list, whatever you want to call it. There's our rule. Okay, let's apply that exact rule right here. Now, first thing that, this is pretty general. If you wanted to look at this, how do I go from a squared to a? What do I do? Forget about everything else. It's just the square root. A squared, take the square root, it's a. What's the square root of b squared? B. And notice I have a and b showing up here. So if you can identify both square roots, these are a piece of cake. So help me out. What's the square root of x squared? X, good. And what's the square root of 36? Does it matter whether I put plus or minus first? Not at all. I typically do minus. I think one of my 2 factors was a minus b, or x minus 6 in this particular problem. And the other one is x plus 6. And it's still equal to what? 0. So the y question is a little bit harder. I can convince you that it works. They're opposites, and don't write this one down, but just to show that it does work, I'm going to distribute really quick. If I unfactor, which is distribution or FOIL, what's x times x? I would not write this again. We're just working it out. What's x times 6? And negative 6 times x? And negative 6 times 36. Dang it. Negative 6 times 6. Okay. Lucy, what happens with these? 6x minus 6x. So do you agree I'm just left with x squared minus 36? Which is what we started with. I can see that it works. I don't know if that really feels good for an explanation so much, other than difference of squares, one opposite, one positive, one negative, so that they fall out is essentially. Okay, that didn't sound like a convinced okay. Like, was that just an okay, like you accept what I'm saying, but you don't really get it?
Okay.
So the big part of it, and I'm just going to try one more time. If these are opposite, it means those middle terms will always fall out, and we'll wind back up there by.
So you got those because of square rooted.
So
that's how you got the first.
it's how I got x and 6, and then I just write them here, and then I know that one of them gets a minus, and then I take those same x and 6, and the other one gets a plus.
But you got x minus 6 because you square rooted x squared in 36.
Correct.
Okay.
Yep. So, yes. And it's not really nice to do here, but I can do this and say, check it out, square root and square root. And that's where the numbers come from. We just have to remember one of them's minus and one of them's plus, which this rule does tell us. 1 minus, 1 plus. Okay. All right. And what did we just use? What's the annotation here? It is a binomial. What type of factoring is in binomials? Good. So I'm fine with just this, diff. I'm good with that. If you want to be more specific so that it's really clear, I'm good. It's the difference of squares. Now, if you read the directions, I just wrote diff is what I suggested for the shorthand, but you can use whatever you want as long as you're not calling difference of squares happy little frog method or something. Like I need to know what it is. Any of these words I probably recognize, just so you know. Okay, are we done? What have we done so far in the problem? Like going from this to this, that's called doing what? We have factor. We're done with the factoring part. Now here's the last part. I now claim that this times this times this, when we multiply them, it has to be what? So, nope, pause. You're right, but not what I'm looking for here, because you're trying to go back the other way. Forget about everything else. What do I claim if we multiply these three together, it's equal to in the end? Zero. And if we're going to multiply three things to be zero, like everybody think of a number right now. Between 1 and 5. Don't shout it. Let's just think, or between 0 and 5. I have my number. What? Give me your number. So I'm not going to tell you mine, but check this out. 3, give me one more number. 4, and I'm going to not do mine. I'm going to put a question mark, and I'll tell you when I multiply 3 times 4 times my number, we get 0. Can you tell me my number?
0.
It had to be 0. If it were 2, we would have got 3 times 4 is 12. We got 24. The only way this happens is if it's 0. Everybody okay with that? Okay, that is a zero product property, and we're going to make sense of. Now, this, we just used 3 numbers. How many factors do we have listed here? Are you sure?
4. 3.
There's 3. There's 3 things. We don't put parentheses around it, but we could. Here's a factor. Here's a factor, and here's a factor. We have 3 factors written out. Now, here's what we have to do. If I know that together when we multiply them, it's 0, then we have 3 possibilities. This first factor could be 0. And I'm going to write this, is this true ever? Is there a value of x that makes that true? And so maybe there could be, but check this. Is there an x in this anywhere? So even if I say x is 5, it still says 2 equals 0. There's nowhere to plug it in. This is nonsense. Okay, there's no x. We're finding x values. It makes sense that that one doesn't work. If you want to get rid of it, you could, but it's not necessary. If this is equal, could I divide both sides by 2? Am I allowed to do this? Yeah, like, and then I see that they won out, and I'm just left with my regular factors. Okay, if it has an x in it, like this one, the factor is x minus 6, and I'm claiming that if it multiplies to be 0, is it possible that this is the one that's 0? It could be, right? This could be 0 or this could be 0. Okay, help me solve this. What do we get?
6.
And you just add 6 to both sides, right? Okay, so one solution or value that makes this true is a 6. What's the other factor that has an x in it? So x plus 6. And is it possible that we were wrong and it was this one that was equal to 0? because all I need is one of them at least, right? It could be all of them, but it could just be one. If they multiply to be 0, one of them for sure is 0. Now, it turns out these are both going to work, but help me solve this. What would you get? So I subtract 6 from both sides, and I think I agree with you. I get x equals negative 6. We have successfully and correctly identified both, how do we word it, roots. So on your test, when I give you this at the bottom in bold, I'm really just asking you to write your answers here. Roots at x equals, what were the two values that we just found? 6, comma, negative 6. There were 3 points. You got 1 point for your roots, you got 1 point for your factoring, and you got 1 point for your annotation. So if you have -3, it's because I made a mistake if that's what you wrote. But if you have -1, my guess is you forgot the annotations. These are my annotations. Yep. Okay. I know that it probably feels nitpicky, but the reason that we write it is because I know for a fact that we're going to be using this language all year long and all year in pre-calc if you take pre-calc. And because we're going to use this language for so long, I just want it locked in like now. Because otherwise we just have to say, well, I did this without being real specific. Okay. Where were your mistakes that we're going to avoid? So you guys forgot one of these, which means when you see it again, are you going to forget it? No, let's avoid that. It's an easy mistake to make, which it happens, easy to fix. Annotation stuff, again, I gave you the shorthands. You can use those. You can use any shorthand that you think is reasonable that I would know what you're doing. Okay, let's knock out number 2. Somebody, I don't know who. Do you guys remember yesterday when I made a big note on the, well, I had the note on the board already, but I told you as soon as I hand it out, we're going to make a change right here, right now. Yep, it's still on the board. I don't know who it was. It doesn't matter who it was. I don't, okay, so I do talk because I like the sound of my voice, but I don't give you stuff about tests and stuff just for fun. My hope was that on number 2, everybody would pay attention when I had that couple minutes at the start of class to say, stress this. Hey, do change this, because I think I mentioned it several times. Somebody didn't. It happens. On number 2, I did not want you to deal with 2n squared. I wanted you to change it to a what? So check it out. Number 2, n squared plus 7n equals negative 10. Okay. In this problem, and I would encourage, whether you got it right or wrong, you would benefit from working through it again, I think. What should we have it set equal to if we're trying to solve it? We don't have a negative 10 product property. We want it to be a 0. How do I make it so that it's a 0 on one side? Everybody cool with that? Yeah. Okay, I'm just going to add 10 to each side. Where? So we'll talk about that. I'm just going to write it like this right now. I'm going to write the expression a couple ways, and I want you guys to tell me which one feels right to you. Don't write all 3 of them, okay? One of those feels better than the other 2. I have 1 vote for the middle, 2 votes for the middle. So this also has a leading coefficient of 1. Do you think it's this one? Which one of these do you prefer, Kian? Second one? Yel? David? Why? So B was trying to express this idea, didn't have the words for it right then. It feels natural to have n to the second, n to the 1, like to descend. We write them down here. That's a normal way that we do this. Okay, that might show up again. I'm going to rewrite it in that regular form then, and we'll switch color here. N squared plus 7n plus 10 is now equal to what? 0. We're going to run through the list. Always the first thing we check. Is there anything that goes into 1n squared, 7n, and 10? No. Okay. Is it a binomial? No. Bummer. So there's a couple ways that we can do this. For example, find me anything that goes into both 7 and 10. Like, I know that this factors as 1 times 7, right?
Yeah.
And this one factors as 2 times 5. Do they have anything in common? Uh-uh. Nothing goes into both of them. That's it. Like, that's the whole idea. Okay. Yell. So we're gonna hit this again because I think you might have zoned out here today for the second time. Yesterday before the quiz, I wasn't gonna say who it was. Yesterday before the quiz, I made a big deal about this on the board, and then I handed them out and said, "All right, now everybody on number 2, let's change this." And then just before we started this problem, I reemphasized, "Hey everybody, we're changing this again. Let's make sure we do it." Cool. Change it to that. Okay, you're good. Like that felt rude, and it always feels rude when I do stuff. Do I have a sarcastic voice? I've been told for years that my voice is super sarcastic, whether it is or not, so people never know if I'm messing with them, which I appreciate that. Um, there is not a single time that I would ever be mean to any of you. If you feel like I am, it's a miscommunication. Please tell me, like ever. Even if I call you out, if I'm giving you a hard time about something and it's too much, I try to use my judgment, and I think my judgment is pretty good. I legitimately, it sounds like a joke, but legitimately, I don't want to be your bullies. Please tell me if you think that what I'm saying is coming off as rude. Cool. All right. It never is. I try to be the nicest person in the world. Cool. All right. So, is it a binomial? How do you know that? There's 3 terms. Okay, so now we're going to go to trinomial stuff. All right. Do you perfect square? Do you know the square root of this? N. Okay. Before you write this, do you know the square root of this number? Nope. Okay, so it's not perfect, and I guarantee it's not perfect. And we'll get a perfect square on here. There's one on your test. You don't have to use it, but it's a good shortcut. What's the leading coefficient? And follow-up question, what does that even mean? So the first would depend on the order that you wrote it in, I think. What's the biggest power of n, our variable? N squared, right? Now, we don't write a number in front of it, but there is a number here, right? What is it? The number that's connected to the biggest power is your leading coefficient. So in this problem, the leading coefficient is 1 right now. We don't write it, but it's there. Okay, if the leading coefficient is 1, and only if it's 1, we have a wonderful shortcut to use. I'm going to multiply, and if you go back in your notes, you may want to put this on your note card, but we have a whole process. Multiply A and C, and I get 1 times 10 is 10. I now need to find 2 factors, 2 things that when I multiply them, it gives me 10, but they have to add up to a different number. 7. Now, some of you can find these right away. Some of you might feel like you can and be wrong, and some of you feel like you can and is right. Whatever category you're in, whether you write it or think it, here's my thought process literally every time. I start at 1. Is 1 and 10 going to add up to 7? No. So what's the next number? I tried 1, 2. 2 and 5 multiplied together make 10. What do these add up to? 7. Okay, what type of factoring are we doing right now? So there's 2 ways you could do it. You could call it grouping, and I would accept it. I would call this leading coefficient of 1, or the shortcut. Now, we haven't really committed to the shortcut yet. We're about to. Maybe we're about to. We'll see if the shortcut makes sense. What do I use these numbers for? Good. I'm going to rewrite this, and I'm going to replace something with these numbers. I take my trinomial, and I make it a 4-nomial. Now, big question here, and we'll talk about this. Do you guys want to try to use the shortcut first, or do you want to go through the grouping and then see the shortcut? Grouping? Okay. So I'm going to say shortcut and grouping, and we'll see both of them here, just so you know. You would never actually annotate with both of them. It's one or the other, but we'll see it. Okay, I'm going to replace this 7n right here with these magic numbers. Like, that's the whole process and why grouping works. So I'm only going to replace that with these. And what I mean by that is I'm going to write n squared. I'm going to leave an awkward gap because I'm changing colors. And instead of plus 7n, I'm going to use these. And the order doesn't matter. Plus 2n plus 5n. Yep. So when I say a four-nomial, that's really not the proper term. It's a quadnomial, but that's nobody ever says that. This is a three-nomial or a trinomial. I'm rewriting it with four terms instead. And I get those terms from these numbers. Now notice this expression and this look very different, right? But if you combine these, are they the same?
Yeah.
Like that's still plus 7 in it. Okay. Now, for grouping, which is what we're doing here, I now am going to put groups around these pairs. Order doesn't matter. I could have done plus 5n and it would have been fine. And now we're just back to the GCF question, which feels weird, but we're going to see it. What could I possibly take out of both of these? A single n. If I took an n out, what would b remain? So it was n squared. Now it's just n plus 2. Now, for this, you can write this down. It's not super nice to annotate. It's kind of wordy. We need the other thing to match. It has to be exactly n plus 2. So what could I possibly take out of this to ensure that I leave behind an n plus 2? Do you guys agree that it's a 5? Okay. Now, I did it kind of backward. If we hadn't thought that out and written the n plus 2 first, you're going to see the same answer. What's the GCF here? So notice we just did the same thing. And if I take out the GCF, it leaves behind an n plus 2, right? Still equal to 0. Okay, this part, it's just foiling the other direction. Like multiplication and factoring are just opposite directions. Just like multiply and divide are opposite directions. They're the same thing. Which piece? Yep, so when we factor out of 5, I want you to think of it as doing this. Yep, factoring and dividing are essentially the same thing, but we don't get rid of it. Now, if these match, and we're going to write this a little bit more clear. If these match, first of all, we're correct. So we're just going to make a note. This is one factor. Okay, specifically, what is the factor? N plus 2. Okay, I'm going to change color here, and I'm going to do it above. Deck, you're good if you're just getting a drink. This is the other factor. Other factor. Now, if we looked at FOIL, we would see this is really what happens. But with that in mind, what is the other factor that we just identified? N in front and plus 5. And it's still all equal to what? 0. Now, just to be super... Okay, so this is the weirdest part. We're going to pretend like we're not in the middle of a factoring problem, okay? And let's clean this up. If I said, and you don't have to write this, we can just talk about it. If I said let's factor or let's distribute these, do you feel like you can FOIL?
Yes.
Okay, so help me out. Do you guys draw the lines when you FOIL? Okay, good. Do you agree the first lines we draw are these? Now, we normally do that as n squared plus 5n, but just bear with me for a second. Do you agree what we're really saying is we're taking n and we're multiplying it by n plus 5? Does that give me the same distribution? I have an n times n and plus 5. This is the same thing of that first line. Really okay with that?
Yes.
Okay. Beatrice, are you okay with that? Yeah. What's the other one? I'm going to take 2 and it does this, right? But that's just me saying that's a 2 times, what did I really just multiply 2 into? We just expanded it using FOIL and writing it a little differently than we normally do. This direction is expanding. And then we could even clean it up further, right? And this direction is factoring. So once we get to this expression, because I can see that it does spit out in FOIL, it means these are equivalent. They're the same expression, they're just written differently. When we factor, we want them to be very specifically written like this.
Why is there a plus 2?
Because what was the number that we multiplied here? And we don't normally write it, but do you agree it's a plus 2? Or if you'd rather, we could say it's this plus 2n plus 10. Yep, so it's just there to separate it so it doesn't look like multiplication all of a sudden. Yep, yep. Okay, So, oh, go ahead. Sorry, I offered a walk. I was not expecting somebody to be bummed when I said it was a joke. Just like Manila, right? Yeah. When I think of Manila, I think of gusty, cold rain. So I'm definitely talking about the city in the Philippines. I'm making a joke because it's not even a little bit like Manila. Or my humor, I don't think this is it, but maybe my humor's just not that great. It makes me laugh, and apparently sometimes Beatrice. All right, this factoring for this, just so we can be ultra clear, this process right here is what we call grouping. Now, here's the cool part of this. I don't want you to erase it. We'll do this on a different problem, but I do want to show you something. I will put all this back on the board here in a moment. But let's pretend that I didn't want to do all that. Is there a connection? Since my leading coefficient was 1, and I really want to stress that, is there a connection between the positive 2 and the positive 5 and the numbers that I wrote down here? They're the same. That's our shortcut. If it's a 1 n squared, not a negative, not a 1/2, exactly a 1, you can skip all the grouping because this is going to happen every single time. Didn't even flip it. I put them exactly here. No flipping. Nope. Nope, not even a little bit. Okay, if I can't stress this enough, inevitably somebody's going, oh my god, this is so easy, it's awesome, which good. You're going to try to do this when it's not a 1. What does it have to be right here? It has to be a positive 1, no other option. Now, Kian, you asked about the flipping part. Where, go ahead. So they do, but we're not at the answer yet. We just did the factors. Now, we have how many factors? 2. We're going to do the same thing. And I realize that most people, even you guys who maybe don't feel like you have a ton of confidence in mental math, I think you can solve these in your head. But if you can't, that's okay. I don't care if you can solve it in your head. I'm going to take each factor and set it equal to what number? Because I'm claiming that this times this is 0, it means this is 0 or this is 0. If we'd set n plus 2 equal to 0 and solve it, how would we get, or what would we get rather for n? We're using the zero product property now. So we've done all the factoring. Here's our factored form. And now we're just going to actually find the answer. What do we get for n on this one? -2. How about for this one? If we do n plus 5 and set that factor equal to 0, Kian, I agree with, we get n equals -5. That's why I asked you. So to go here, yes, but because I'm asking you to show me your factoring too, and I want both of them. Like, flip it for sure once you get down here, or just set each factor and solve it. Now, I want to highlight one other little thing. On the first question, I called them the roots. Here I call them the zeros. They're the same thing. They're synonyms of one another. Roots, zeros, solutions, x-intercepts. Okay, all four the same. We're just looking for the answers. Okay, now, because it's really important that we recognize that there's 4 different ways to talk about these, because your book, your test, the SAT, the ACT, it'll show up, find me the roots, find me the zeros. Yep. Baller. I'll probably be proctoring it. I won't be proctoring, but I'll be working while you're doing it as a tech person. I don't know, like 6 hours? No, it's like 2.5. All right, so check it out. We have 2 of them done so far. Let's keep rolling. Questions here before. What were your mistakes, out of curiosity? Okay. Oh, you're the one that came. Yep. And I could tell what you were doing, and you were close to grouping it like well. You just had a little hiccup. Yep. All right. Here's this one. What do I want this to be equal to, Wenzel? What do we always want it to be equal to if we're solving? One more time. What do we want this? So I think it's what he said. Like, what do we want this to be equal to? 0 every time. Okay, how do I make this a 0 over here? Okay, where should I put it?
After the 72.
So does this feel natural to you?
Yes.
I'm going to go back to that other one. I might have erased them. Does this feel more natural, Lucy? And we're going to rewrite it. I'll tell you, this is not what I'm hoping is natural. What feels more natural to you, or what looks more organized? Why'd you change your mind? We want k squared and then a k. Let's rearrange it in descending order. Like, pretty standard that this happens. If you're thinking to yourself, Holloway never mentioned that, that's BS, what a crock. Maybe, you probably don't think about it that aggressively, but I bet you have this in your notes, where it's ax squared and bx in c. That is this order that we use. Cool. I don't think anybody was that aggressive in the thought, but all right. So here we are. We're doing another problem that we're going to solve by factoring. I'm always going to check for what first, Kian. Indeed I am. Now, these are bigger, GCF. Is there anything that goes into all three of these? I think a 3 does. Now, for sure a 3 goes into those. If you had to check, could you use your calculator? 3 times 20 is 60. 24. So, check it out. I'm going to factor out a what then? 3. What does it leave behind? You missed a word. It's definitely not 36, Kian. Good. Now, this 3, we can keep it along for the ride, just like we did on the first one, which is what I would normally do. Alternatively, you could just divide both sides by 3 and be done with it, but I'm going to keep it along.
Wait.
It was never cubed.
It was cubed on my paper, not...
Flip, like, on the problem that you just wrote down, or on the front side, you think? Jade, are you sleeping? Are you working? Okay. All right. So it's not, but easy mistake to make. Cool. All right. So let's keep kicking forward. We're only going to focus on this one. I can't break down this number anymore, but let's roll back through the list. Any more GCF?
No.
Is it a binomial? Is it a trinomial? Okay. Anything special about the trinomial? The perfect square stuff, I'm okay if we don't even pay attention to the perfect square stuff. Like, we'll see it again. It's going to show up. So let's just skip that. It's not a perfect square, but we'll skip it for now and say no. Okay, what's the next thing I should check for then? We're in trinomials. Perfect square, and then what? What do we check for?
Oh, it's the leading coefficient.
What is the leading coefficient in this grouping? That's a 1. That is a great sign. It means what? Shortcut. I'm going to factor multiply 1 and 24, and we get a positive 24. Here's where it gets weird. We need two numbers that multiply to be 24, but they add up to what? Negative 11. Now, here's the weird part. If they have to add up to a negative, but multiply to be a positive, they both must be negative. They both have to be negative. Now, some of you guys are already giving me the numbers, and I'm cool with it. If you can find them quickly, awesome. I struggle with that sometimes because the numbers are big. I'm just going to go negative 1 and 24. Negative 24 to ensure that they're positive. Do these add up to negative 11? No. Okay, so we'll try the next number. Negative 2 and negative 12. Do those add up to negative 11? No. The next one, negative 3 and negative 8. Those do. Okay, we're going to forego all of the grouping stuff. I'm going to write GCF here because I forgot to do that. That's what I did the first time. Now we're going to employ our shortcut. The only thing that I'm worried about you magically disappearing out of this problem is the other factor that we've already pulled out. What was the common factor that we took out at the beginning? We wrote it. I can see it. What? 3. We didn't get rid of it. It's still there. There's still a 3. It's still there. Okay. How do I use a shortcut then? Here's my number, negative 3 and negative 8. how did that shortcut work on this one? 2 and 5, they're both positive. Here's the positives. Minus 3 and k minus 8. Say it again. Nope, I'm factoring. We're using the shortcut to get rid of all that grouping. You could group it and you get to the same answer, but if this leading coefficient is 1, we just skipped over all this because this is always going to happen. So, yep, and I'll even do the longer problem real quick and show you that it doesn't have to be super long. 3, and then I'm not going to change colors is the only thing that's going to happen. K squared minus 3k plus negative 8k plus 24. Nope, this is me just showing the factoring. Like, you don't have to do this. You should use a shortcut. But I want to show. In this group, what could we take out? A k, and it leaves behind a k minus 3. Is there anything that you could divide these by to make this be a k minus 3? Positive or negative 8? Because it has to be a positive k. It's not k. It's 8. And I think is that what you said, Winslow? Somebody said 8, or I misheard. What could I take out of these two to leave behind a k minus 3? Positive or negative? Let me rephrase this, because I can't tell if the silence is just people are not sure, if it's super boring. It might be boring. What do you divide this by to leave behind a single k? This is what we need. 8 won't do it. That'll leave behind a negative k. Negative 8 will do it. If we divide or factor out each of these, a negative 8, this leaves behind a k. What's 24 divided by negative 8? And check this out. Kian, you were asking about all this, but notice one of my factors is a k minus 3. And what's the other one? What's the other one? I don't think so. K and minus 8. Notice, just like before, is that what we got when we did the shortcut? You can still group it. That's fine. This is much more efficient if we just skip that part, if that leading coefficient is 1. Okay, we just did, if we don't include this part, what is this justification? If we did all this, I would call it grouping. What if we didn't? Like your page. That's a leading coefficient or the shortcut? Shortcut. Okay, at this point, we're in that same situation. Does this have a k in it? So no matter what we pick for k, it's always equal to 3, right? That's not going to have an answer. Like, there's nothing we can even do. We're going to try this one without doing it. What are we going to set this equal to? 0. And to solve it, you would get what value? 3? How about from this one? I think it's positive. And if you're struggling with that, do the extra step. K minus 8, it has to be equal to 0. Add 8 to both sides. Typically, yes, but if it gets more involved, I'd be careful. Like, you're not wrong, but you're not entirely right. Okay, here are our solutions, maybe we'll call them. Or give me another word we could use instead of solutions. Roots, zeros. And number 4 is pretty much already done. Okay, feeling okay so far? Are you feeling better about factoring right this second than you were yesterday? Okay, let's do one more. 4 is going to take us 2 seconds. Here's a function, f of x equals x times x plus 3. Now, I get the, like, I'm not trying to trick you. And maybe this felt like a trick question. That was not my intent. Everything that we've been doing today was just to get into factors, right? Which is just simply saying this times this is my expression. What's happening between x and x plus 3 right now? I agree, it is factored, but are those just multiplying? Yeah. Which is exactly what every single factorization problem ends up at. This is already in factored form. If I'm looking for the solutions, or what did I actually ask for on number 4? The roots. To find the roots, we simply want to know when it equals what? 0. It's like I just do this. Now, this times this I'm claiming is 0, right? So there's only 2 options. And this one always feels goofy. This is a factor right here. What value of x makes this 0? And it's not a trick question. Yeah. What value of x do I need to make this thing right here a 0? Okay. No, you're right. And it's a weird question to ask because even if I asked you to solve the equation for x, I'd say, okay, solve this. X minus 0 equals 0. Like, it's still a weird question. That one's 0. What value of x makes this one 0? X plus 3 equals 0. We're done. It was already in the factored form. There was nothing for you to factor. All I was hoping for there is that you would look and see that it was already factored. And Jade, shout out to you because I saw that you physically wrote this is factored form on the test. Good on you. Here they are. Okay, we are going to look at number 5 together, or do you guys want to try number 5 independently? Okay, x squared minus 6x plus 9. We're going to split here. I want you guys to use, we'll run through the list. To start, I want you guys to solve it, but I'm going to run through the list with you. Is there a GCF anywhere? Pro tip. You say yes, what? How many times is 3 going to 1x squared?
0 times.
That'd be 9x squared. None. Now, here's a general rule of thumb, not perfect. If this is a 1 and they don't all have an x in it, there's no GCF. Like, there will never be. Because 1 is a prime number, it doesn't have any common factors with other stuff. I'm so excited to walk my dogs after school. I usually just take him over to the park and let him run around because my dogs are not good leash dogs. Yeah, one of my dogs, pretty sure has autism, which I don't know if dogs really can. I think so. I don't know. He has either autism or OCD. He's crazy. He has. They definitely do. Down syndrome dogs are super cute. If you've ever seen one, they kind of look like Boston Terriers or pugs. Which, anyway, we're getting too far away from this. Ask me about my dog's autism another day. Okay. Here's this lovely expression. We're just going to run through. Is there a GCF?
No.
Is it a binomial or a trinomial? It's a trinomial. Is there anything special that you notice about this trinomial? The leading coefficient is 1. What's probably going to work then? Try the shortcut. Try the shortcut for me. I'm going to factor it a different way. I want you guys to do the shortcut. Cool. Try it out. Let's see what we come up with. Don't look at my screen because I'm doing this. Nope, I'm just going to do the shortcut too. I'm not even going to show us the other way yet. And I'm actually going to come and be nosy. I try not to look at your pages, but I'm physically going to look at your pages and see what you're doing. So if you're struggling with these, like this R is for the bottom. Like this is where if you're going to make mistakes, and I can tell you were thinking because you were down. If you need to do this, I would encourage it. Let's try it. 1 time. Okay, so that doesn't add up to this. That has to add up to this. So 2 doesn't go into time. There's a 3. 3 times what? Good. And then write those numbers, and then we'll look at one thing. There's only 1 and 9, and then 3 and 3. But those aren't quite right. Good. They both have to be right. Because they have to multiply to be a positive number, so they better both be negative. Because the negative sign.
I thought I was trying to find 6.
So we need factors of 9 that add up.
Yeah, but then this would have to be negative 3.
Yeah, and so is that one.
But then that would make it a positive. We're not multiplying to add.
So we're doing both. We're doing both. Negative 3 times negative 3 is a positive 9, which is what I'm after. And then what do these add up to? Now we're good. Did we find negative 3 and negative 3?
Yeah. What is negative?
You have one mistake, but we're going to fix it. And I want you to tell me why you made it, but you might not see it yet. Okay. We get 9, right? And then I need 2 numbers that multiply to be 9, but they add up to negative 6. 1 and 9 won't do it. 3 and 3, if they're both negative, it still works. Okay, so let's use this shortcut. Now I'm going to replace this with a 0 because I'm solving the zeros. 0 equals, and help me factor. What's 1 factor? Not x squared minus 3. X minus 3. And this one? Nope, still minus, because we just use these numbers. All right, Wenzel, big moment of truth. Do you have this exactly written on your page? Do you? Did you erase something?
No.
Are you sure you do? If I come over there and I look at it and you have something slightly different written, do we have the exact same thing written here right now? Where did this come from? It's a big question. Okay, get rid of it. We don't need it. Okay. Now, at this point, you might notice they're the same. That's okay. Now, this one, I gave points to anybody who answered the question right. I'm going to change it. It's not going to be the x-intercepts. I'm just going to call these roots. Where are the roots of this? What values of x make either of these 0? Positive 3 and a positive 3. Do you want me to write a 3 again? Okay. It's 3 and 3. Yeah, because every time we do this, Beatrice, they just happen to be the same this time. Now, this one was a perfect square trinomial. We don't have to use it. We can group it. I'm fine with that. I'm sorry? I did keep those numbers. I'm not sure. I'm not quite sure what you're asking, Ken.
Because I thought like once you get those two, like once you get negatives, that's it.
Nope. You got to write your factors and then use your factors to get your roots. Okay. The last one. What do we set every polynomial? And these are polynomials. What do we set everything equal to when we're solving? However you want it, right? 0, 0, 0, 0, 0, 0. Okay. Should we do one more? Okay. What kind of factoring do you want? What type of factoring did we just do here? I didn't write it. So trinomial and binomial are never the answers I'm after. It's either going to be difference of squares, grouping, or shortcut, realistically. Okay. Perfect square trinomials. This was one. We didn't go over that today. I'm cool if you use grouping. Do you guys seemingly are okay with grouping right now? Okay. Anybody not okay with difference of squares? Yeah. All right. Let's solve this. This is another fun one. Is there a GCF? You should check using your calculator if 3 goes into 48 first before you commit to now.
3 doesn't go to 2.
What's up?
Oh, 40
But it does.
Where's your 2? Just out of curiosity. Because I think Kim, and I could be wrong, but I think you keep looking at this one and trying to use that.
No, I'm thinking like 48 goes to 2.
Oh, good.
I'm thinking that would go.
I think 3 goes into 48. I think 2 goes in as well. So does 3, which means so does 6. Because 2 and 3 do. Because 2 times 3.
Oh.
But I think 3 does. And in fact, I know 3 does. When I factor a 3 out, it leaves behind an x squared minus 16. What did we just do? We haven't done the difference of squares yet. All we took was the greatest thing in all of them. Cool. I'm going to assign something to the thing tonight, and I'll have you guys check again tomorrow, okay? All right, we're going to finish this problem, then you guys can go. You can stand up and leave right this second if you want. Okay, let's look at this piece. Just the inside now, because I can't do anything else with this 3 other than bring it along. Do you guys know the square root of this? 1x. I would agree. Do you know the square root of 16? Is it a difference between them? So check it out. Here's my 2 numbers, and I can even jump the gun here and write the other one as well. All I need to do is put signs in between here. What do you want here? Minus. Sure. What do you want here? We have it successfully factored. Because it doesn't matter. Because what's 2 times 3? And what's 3 times 2? Doesn't matter which order we multiply in. The real answer is because multiplication is commutative, but the fact that you can tell me they're both the same.
Oh, is that because this?
It's because our number, yeah, we used grouping. We got -3. Now, peace out, guys. If you want to see it, if you hate difference of squares, And again, you can stand up and walk out. You're good to go. It will not offend me one bit. But if you like grouping or the shortcut, but you don't like this, do you agree that this expression is still this? So you say yes before I've done writing. Is that, no, you're good. I'm being snarky. Is this the same thing as this? Can you find me factors of negative 16 that add up to 0? So it's not 1 and 16, it's not 2 and 8. Could it be 4 and 4? And if it has to be negative, one of them better be positive. Hey, check it out. If we add the 0x, could I just shortcut this? X minus 4? And x plus 4? You can still shortcut. Difference of squares is easier, but you can shortcut. The king of factoring in your worlds right now, realistically, is grouping. Every single one of these can be done with grouping. The others are there to save you tons of time, because my goal is that by the end of the week, this takes like 15 minutes to do this, whichever version. Cool. Yeah, let me print some. I'll print a bunch of them.
Monday meeting or it was Halloween.
Hey, Mr. Wolford.